All right. Okay. Hello. Let's get into what we're doing today. So solving systems of equations by elimination, that's what we were working on yesterday. And solving word problems by using the systems of equations. So working on word problems, that's what we got going on today. So when working on word problems, there's a few things we got to look out for. First thing is to define our variables because we want to know what we're looking for. And there's usually two things, and that's what makes a system of equation, well, a system of equations is because there's two things you're looking for, or there are two things that we're looking at basically. And sometimes one or both items are missing. So we have to kind of make a list of what we're looking for. And that's also going to help us make a list of what we're looking for, so that way we know what we have and what we're looking for. So set up two equations. Make sure you use the information you're given. So again, every word problem kind of has three parts, just like an English paper, right? So there's three parts. There's an introduction. Sometimes they call this the exposition, and then there's the body. And this is where your clues will be, or what we're looking for to set up the equations. And then there's the conclusion, but in this case here, we don't call it the conclusion. For word problems, we generally call this the question. So there's always something, and it says like, how many of this item are we looking for? What is the weight of both items, or something along those lines. There's something that kind of tells us what we're looking for. And that's usually a lot more helpful than you might think. All right, so those are the three things that we have when we're looking at systems of equations. Let's go ahead and get into some of these examples right now. All right, so actually we're going to start from here. Okay, so introduction. At the fast food restaurant, okay, so we know we're talking about a fast food restaurant. There are 4 cheeseburgers and 5 small fries, have a total of 2,310 calories. Okay, so this is going to be one of our clue statements. All right, one of the things that we're going to use. In fact, you could probably even make this an equation right now. All right, and it says here, there's a second part where 3 cheeseburgers and 2 small fries have a total of 1,330 calories. So how many calories does each item contain? All right, so there's our question. How many calories does each item contain? All right, so we're going to have to kind of eliminate one of these, so that way we can solve for one of them. So I'm going to put, for defining the variables, I'm going to put C is cheeseburger. And then we would also have, I'm going to put F for fries. Now in this case, they say small fries. Small fires. Anyway, so small fries. Because I'm sure if you have a different size fries, it's gonna be a different calorie load. Anyway, so let's see, there you go. So now we need to know how many calories each item has. So to get this one here, so let's go ahead and put our first clue statement together. So 4 cheeseburgers, so 4C plus 5F equals 2,310 calories. And then the next one says 3 cheeseburgers, so 3 cheeseburgers and 2 small fries is going to be this many calories, 1,330. So how many calories does each item contain? So now we're going to have to change one of these equations. So we covered a little bit about elimination yesterday, so hopefully we're a little bit better about this. But we want to pick one of these. So looking at C, we can eliminate this by making both numbers into 12. That would mean I'd have to multiply this top one by 3 and the bottom one by 4. But I think an easier thing to do would be to multiply it to get 10 for F. So that's what I'm going to do here. So I'm going to multiply this by 2 and multiply my bottom one by 5. But I'm also going to have one of these negative, because I can't just have them both 10F, because if they're both 10F, then they're going to make 20F, not eliminate, and I want them to eliminate. So what I'm going to do is I am going to I'm gonna make this one. I don't know if it's gonna work, and I mean, actually, there is no wrong way to get this. They're both gonna work out, but I guess what I'm trying to do is I'm just trying to avoid a negative if I can. If not, it's not a big deal. Okay, it's not going to be a big deal to have a negative. So let's go ahead and double everything here. So 2 times 4 is 8c plus 10f. And double 2310, or that'd be 4,620. So there you go. That was kind of easy. Let's go ahead and make everything on the bottom multiply it by -5. So this would be negative 15c minus 10f equals, and now this one I don't know, so I'm gonna have to use my calculator, 1,330 times 5, and that would be 6,650. There you go. Now, remember earlier I was talking about which one to put the negative on. If I had put the negative on the top one, that would make this step here a positive number. But in this case, it looks like we're going to have to deal with a negative number, but that's not a problem at all. I don't think it'd be a big problem. All right, so here we get 2,030. So this is basically like saying that 7 orders of fries, and this is actually also negative as well, because 6,000 is larger than 4,000, and that's the negative number, this one here. So if I divide both sides by -7, it's not going to change anything. I'd still get a negative divided by a negative, and you can't have negative calories, right? And again, always make sure that something will pass the sniff test, all right? So like if I put 29 calories, does that sound plausible for fries, an order of fries? No. 29 calories is like unflavored crackers. So in this case, it's supposed to be 290. So sometimes that happens. Sometimes you'll put the wrong number in a certain place. Or in this case, if you might forget the 0. So give it the sniff test. Look at your problem and say, does that make sense? And chances are you probably just don't know enough about calories to really make a judgment on that. But yeah, 29 calories would be super low. That'd be like, again, unflavored crackers. But in this case, 290 calories for a small fry seems reasonable. All right, so now we know that the fries have 290 calories. So let's plug that in and find out how much we have for the cheeseburger. So here, I'm gonna use the bottom one, and I don't know if that is easier or anything, but we know that the fries are 290 calories. So I'm gonna plug that in for F. So now we know that we bought 2 of these, right? So these plus the cheeseburgers equals up to this number. So what we have to do is we have to ignore this cost. So 3C plus, and then 290, I'm sure that'd be 580, but so 580 equals 1,330. And now I'm gonna have to minus, because we know that 580 of these calories come from the fries, so we're gonna have to minus that. So now we're just looking at here, so 3 orders of cheeseburgers is gonna be about 750 calories. And I'm just doing basic algebra stuff on here, so it's not really anything different. All right, so I know sometimes it might be a little bit difficult to keep up with this, but this is just basic algebra. So what number times 3 gives me 750? Well, that should be kind of easy. Or wait, divide that by 3 and we get, oops, sorry, I pushed the wrong, looks like I pushed the wrong button. Oh, you know what? I think I did make a bit of an error here, because I was supposed to plug it in for C, and I did not plug it in for C. I plugged it in for F. Oops. I don't know how that happened. That's so weird. So I know the cheeseburgers are 290, and now we're looking for the calories on the fries. Okay, luckily I caught myself on that. So in this case, it should be 870 plus 2F equals 1,330. And I'm gonna have to minus 870 on both sides. And that'd be 460, so 2F equals 460. Divide that by 2 and we get 230. So F equals 230. I'm going to put that over here just because I'm out of space there. If you got the space to write it, go ahead and write it on your paper with the right space. Now for this one here, we have both numbers. So 290 for the Cheemsburger. And then, let's see, I'm gonna have to put the next one down here. So what was the fries? 230 for the fries. All right, so something like that. So 290 calories for a cheeseburger and 230 calories for the small fry. Whew, okay, so again, don't be afraid to check yourself. Okay, it's pretty easy to make a mistake like that. So if something doesn't seem right, back off and see what's up. All right, so next one, let's see. A homeowner used 150 units of gas and 520 units of electric for a total cost of $84.20. The next month, 210 units of gas and 405 units of electric were used for a total cost of $82.35. Find the cost per unit of gas and electric. Okay, so this person's using two different things, and there's our introduction. A homeowner used this much gas and that much electric. And it kind of goes right into the whole thing. And in fact, actually, there's not really much of an introduction statement. So let's go ahead and just get started. So here we have 150. And I'm going to go ahead and let's see what we have. So I'm going to put E for electric and G is gas. Let's keep it simple. We don't need to make it more complicated than we have to. Now we should have enough to write out what we need. All right, 150 gas and 520 electric cost $84.20. The next month, so now this is a new month, we have a separate bill, so 210 gas and 405 units of electric were a total cost of $82.35. And it just says find the unit of gas on electric. So it doesn't say anything like kilowatt hour or gallon of gas or anything like that. So now we're gonna have to find a way to get this to work out. So let's see, what number could we have them meet up at? So one thing you could do is make a list or kind of just ignore these numbers here. And you could even do this without it, but if I count by 15s, that'd be like 15, 30, 45, 60, 75, 90, 105, something like that, okay? And then I do the same thing with 21, so count by 21. Well, you could make a list, 21, 42, 63, 84, let's see, 105. Oh, and there's 105 again. So we know that this number here should be 105, because remember when I was counting by 15, I said the same thing. I said 105, so 15, 30, 45, 60, 75, 90, 105. So we know 105 is where these two numbers meet up at. So sometimes it's good to just ignore some of the extra numbers. Oopsie, too far. So in this case, I know that both of these are going to meet up at 105. And if I did, like, see how I ignored that? I'm going to have to bring that back. So that means I'm going to need to find a way to make both of these numbers into 1,050. So again, 105 and then bring back the 0. So that's a way to kind of keep things easier. So and I know sometimes when people see big numbers, they're like, oh no, big numbers, what am I going to do? I can't solve it if it has big numbers in it. Okay, so let's go ahead and find out what we have to multiply by here to get there. So that'd be 7. So I have to times everything on the top by 7, and I'm gonna have to times everything on the bottom by 5. So when I made that list, there were 5 numbers there. So that means I'm gonna have to multiply it by 5. And in this case, I'm gonna make my bottom number the negative. And that's sort of more of what I do. In general, I notice that I tend to make the bottom number negative. I don't know if that's just how it works out or whatever. But in this case here, again, even though we had two negatives, it still worked out. Okay, so let's go ahead and times everything by 7. So 520 times 7, that's going to be 33,640 E. And this is supposed to be G here. I almost forgot the G. I was too focused on the numbers. And then the next one here, I'm going to have to multiply this number. So 405 times 5, that'd be 2,025 E. And then I'm still multiplying this by 7. So 84.2 times 7. And this would be 589.4, and multiply this last number, 82.35 times 5. So this would be 411.75. Okay, hopefully I didn't make any mistakes there. Let's go ahead and put them together. And that should cause this one to cancel. Oh, wait, you know what? Looking at the sign, I noticed again, I almost forgot the sign. So this is why, again, don't think to yourself, oh, I didn't make any mistakes. Because it really is easy to do this. So in this case here, it was an easy one, but I stopped myself because I noticed that both of these should have been negative. And that's kind of what I try to tell other people too. Check every step, and as you're going through it, if something doesn't feel right, back off of it. So in that case, I know it didn't seem right because normally we would have to subtract one of these numbers, and then that's just the case in most cases. All right, so I'm going to go ahead and take this number, so 3640 minus 2025, and I get 61615E. And then I'm going to have to do the same for the other side, so let's go ahead and do this one. So it looks like I have $589.40 minus $411.75. And that gives me a cost of $177.65. Now, this one might look like a weird one because this number is 10 times bigger than that number. So you might be thinking to yourself, wait, how can you multiply something to get that other number? Well, okay, so let's just keep going and see if the answer makes sense. Oops. 1615. Now I'm going to go ahead and take that number and divide it by 1,615. And this gives us our unit of electricity, which again, we don't know what it is, but just by guessing, if I had to guess, by wording, how this is worded, I would probably have to say this is like a British type question. I mean, I could be wrong. That's probably why it says unit of electric instead of something like kilowatt hour or something similar to that. Or they probably just wanted to keep it simple. Anyway, so there we go. Now a unit of electricity is about 11 cents. Now I don't know exactly what this means. Maybe that's like the cost to run a TV for an hour or something like that. I don't know. But anyway, we have one of the answers. So let's go ahead and plug it back into one of the originals and see if we can get something to work out. So I'm going to use the top one. And again, it doesn't really matter which one you use. You can use the top or the bottom. I'm going to use the top one just because it looks like it has smaller numbers. It probably doesn't, but I'd rather just get it done with instead of having to agonize over the choice of which one is easier. Sometimes it's easier to just get things started rather than overthinking things. So anyway, I'm going to go ahead and multiply this here. So 150G plus, and this is going to be, now we know that this bill, this $84.20, $57 of that was the electricity. So if I want to find out how much the gas was, I'm going to have to ignore that cost here. So for 150 units of gas, I'm going to have to minus Yeah, I'm gonna have to minus 57.2 from both sides, and that would be 27. So 150 units of gas is $27. So I'm gonna have to divide both sides by 150, and this comes out to be gas equals 0.18. And that's the second part of the solution. And I could check this by plugging it back in. If I plug it back into either of the equations, I should be able to get the whole thing to balance out. But anyway, let's go ahead and put this here. So 11 cents per unit electric, and I probably should be a little bit more descriptive, but I'm going to end up cramming these in there. And here I have 18 cents. And actually, I should put a dollar sign here because that's how you would write cents, like that, right? Because it's not exactly a dollar, but it's 1800ths of a dollar per unit of gas. And that's kind of stuck in there. But anyway, we're done with that one now. So hopefully we can move on. And there's not really that many. I was kind of hoping this wouldn't be that long. We only got 4 slides of this, but it did for my previous class. It took pretty much the entire class period. So I'm going to try to keep things moving along here, just to keep the pacing good. So just try to keep up. I'll try to make it easy on you guys. All right, so here we go. Kim is renovating the first floor of her home. She bought 750 square feet of laminate flooring and 525 feet of carpet and paid $2,717.25. She went back to the store and bought an additional 100 square feet of laminate flooring and 75 square feet of carpet and paid $374.75. Find the cost per square foot of each type of flooring. So again, there's an introduction statement right here. It says, Kim is renovating the first floor of her home. So we know that there is going to be home repairs happening. First clue statement is this part. So 750 of laminate, 525 of carpet, and that was, this $2,717 amount. So we should have enough. So let's go ahead and define our variables first. So the first thing we want to do is define L, and we'll just have that. A lot of times you don't really need to come up with something really drastic. Okay, just L for laminate, C for carpet. All right, so we identified our variables. Let's go ahead and put our equations together. So let's see, first statement says 750 of laminate plus 525 of carpet equals $2,717.25. And it says here she went back to the store and bought even more stuff. So there's 100 square feet of laminate and 75 square feet of carpet, and this was $374.75. And that's our second clue statement. So again, especially with systems of equations, there's going to be 2 clue statements, or 2 body statements was the other thing that I was calling them too. And those are where you will find your equations. These ones are pretty straightforward because you can easily just build it. I was able to just read it as I was going here. So like 100 square foot of laminate and 75 square feet of carpet and paid $374.75. So these are pretty straightforward. Some of these are not going to be very straightforward, so you're going to have to do a little bit of thinking and try to find a way to get try to get more meaning out of these. Anyway, so next thing we got to do is we got to probably to get one of these to eliminate. So if we look at the L variable, it's going to be really hard to multiply something to get 750, which we also want to avoid decimals. I could also make both of these numbers meet up at something like 1,500 or 1,500. But I'm going to see if I can make this. So I'm going to take 525 and I'm going to divide that by 75. So I'm working backwards. I'm trying to think, is there a number that I can multiply by 75 to get 525? And in this case, we're in luck. There is. So in this case, it would be -7. Now, it would just be 7, but again, I want one of these to be negative. So I'm going to multiply this whole second equation by -7. So -700L minus 525C equals negative. So again, make sure you watch your sign. So I'm going to have to multiply this number. So 374.75 times 7. And I'm going to have to remember that this is going to be a negative. So 2,623.25. All right, so there's a lot of stuff going on. And I'm going to try my best to ignore this. Normally, I'd cross it out. But I'm thinking that this is actually going to come in handy again. So just remember, we're working with the top and the third equation here. We're going to ignore the middle one. So I'm going to go ahead and subtract it. So 750 minus 700 is going to be 500. And again, that's this number minus that number. And then here we should have these cancel out. And again, we chose 525 for them to meet up at. So hopefully that will eliminate. And now I need to subtract these two numbers. So let's go ahead and I'm going to subtract that right now. And that would be 94. So 5 square feet of laminate flooring would be $94. So how much would it be for one? Oh, actually, hold on. You know what? I did almost make a mistake here because this would be 750 minus 700. So that wouldn't be 5. That'd be 50. Now, looking at that, that would have been like, 5 square feet of laminate is $94. You mean it like enough to cover maybe like a regular person's body would be $94? That's a lot for flooring. So again, if something doesn't seem right, in that case, it did not pass the sniff test. And nobody would ever buy flooring for that much money. But if I said 50, now that $1.88 a foot, so 1 foot of laminate flooring is going to be $1.88. That sounds more reasonable than something like, if I had left it that way, it probably would have been something like $18 a foot. Okay, so and that's a pretty good lesson, because if you ever notice that something's not adding up, something doesn't seem right, something just costs way too much money, it probably is not, it's probably not what you're looking for. All right, so the next thing here, so now we know how much the laminate flooring costs. Let's see if we can find out how much the carpeted flooring costs. So I'm gonna have to plug it into one of these original equations. And the reason I did not want to mark this one out is because multiplying by 100 is actually very easy. So 100 times $1.88 per foot plus 75 feet of carpet equals 374.75. And now it has a little bit of a smaller number, so it's easier to, I would imagine it's a little bit easier to work on. And multiplying by 100 is pretty easy. If there's a decimal, scooch that decimal over 2 places. So this would be 188. Now we know that this person bought 188 square feet of the laminate flooring. So we're going to remove that cost from the total. So 374.75 minus 188, because we know that we just want to know how much they spent on the carpet. So if they bought 75 feet of carpet, that would have been $1.8675. So again, we removed the cost of the laminate flooring and we're focusing on just the carpet. Divide this by 75 and we should get another kind of reasonable number of carpet is about $2.49 a square foot. Okay, and chances are you probably haven't gone by your Home Depot and looked at prices of laminate and carpeted flooring. So you probably might not have an idea of exactly what you're looking for. You know, I mean, to somebody, 18 feet of 18 feet of, or sorry, $18 a foot of flooring might make sense. Maybe if you're, I don't know, using some kind of fancy floor. But sometimes you just have to know a little bit about what's going on with the word problem in order to get it. So anyway, let's go ahead and write down our answer. So $1.88. And I'm going to go ahead and say per foot. Now it says per square foot of that, but I'm just going to say per foot of laminate. And I'm still going to have to move this over somewhere. Or, you know, maybe I could shorten it by just putting a slash and put FT. And actually, if you were going to go shopping for this kind of stuff, that's probably what it would say. And then here we have $2.49, so don't forget our $, $2.49 per foot of carpet. And I'm going to switch sides just so that way they're not. In this case, I can fit it without going over any of the writings that I had before. And there we go. So that one is done there. The only thing that I think was a little bit tricky with this one is that you had to only use for the first step, you had to only use the top and the bottom equation and ignore the middle one, because that middle one, we changed it into the bottom one. Okay, so let's see what we got here. Sean bought 1.8 pounds of gummy bears and 0.6 pounds of jelly beans and paid $10.26. He went back to the store the following week and bought 1.2 pounds of gummy bears and 1.5 pounds of jelly beans and paid $15.09. What is the price per pound of each type of candy? All right, so it looks like we're looking at 2 types of candies. So let's go ahead and identify some variables. I'm going to keep it easy and go with G for gummy bears and J for jelly beans. Okay, so let's see if we can get an equation going. So we're going to break it down by the week, because he says here he went there once and then he went back the following week. So that's a clue that we're looking at 2 separate weeks. So on the first week, let's go ahead and put that down, 1.8 pounds of gummy bears and 0.6 pounds of jelly beans were $10.26. And again, there's our first clue statement. Second one, let's see, and bought 1.6 pounds of gummy bears and 1.5 pounds of jelly beans. And that was $15.09. So there we go. Now we have our 2 equations. We need to find a way to get one of these to eliminate. Now think of looking at these 2 numbers, 1.8 and 1.2. You could make a list. So make a list of multiples and see where they meet up at. But if you remember one of the questions, I think it was, we ignored one of the zeros. I think it was the last one. So let me go ahead and just show you again what I was talking about. Like here, remember how I ignored the 0 and I treated it like it was 15 and 21? The good thing about decimals is that they oftentimes don't change their behavior just because you did something like that. So like in this case, if I have 18 and 12, what number would they meet up at? 18. So if I were counting by 18s, I could go to, actually in this case, I think it would be 36. So I could use 36 for the G, that works out. But actually there's a better one that I could use. If I go by this one here, so I'm going to ignore the decimal, and this is going to be 6 and 15. So remember, if you count by 6s, you'd be 6, 12, 18, 24, and 30. So I think I'm going to go with this one here. I don't know if it's better or worse or what, but I'm going to eliminate the J, only because I have to multiply it much less than this one here. Actually, I think they'd both be about the same difficulty. I don't think either of them would be much easier than the other one. Now remember, in this case, actually, you know what? Let me bring these back, because remember that in this case we are talking about decimals. So this is 0.6 and this is 1.5. So if I put the decimals in there, it's actually going to be 3.0 is the number that they're going to meet up at. So actually, that's what I wanted to show you, was they're going to meet up at 3.0 or just 3. So I'm going to need to multiply both equations in order to get that the j variable to be 3. So what can I multiply them by? So 6 times 5 would be, or 6.5 would be 30, but then again, the decimal is going to cause it to be divided by 10, so that's going to be 5. And then this bottom one, we already know is going to be 2. And I'm going to have to change one of these to be a negative. I'm going to pick the bottom one to be a negative. And again, you can pick the top one to be a negative also, and it wouldn't change much. You would just have both of them be negative in the last step. But hopefully if I did this right, I can make them both positive. All right, so let's go ahead and multiply everything on the top by 5. So 1.8 times 5, and that would be 9, plus, and this should be 3j, and this should be, should be 10.26 times 5, and that'd be 5130. And I'm just multiplying it using my calculator. So the bottom one here, I have 1.2 times 2, and that'd be 2.4. Plus, and in this case here, it should be 3j. Oh, plus, what am I talking about? I got to remember that it's going to be negative. So watch out for those. Again, watch your signs. So on this second one, since it's all positive over here, if I multiply it by a negative, they should come out to be a negative as well. So 15.09 times 2. This one's going to be a pretty easy one, 30.18. Now, if I had made the top one the negative, my bigger number would be negative here, and the bigger number would be negative here, and my bottom, the smaller numbers would be positive. So in this case, I did manage to make it work out, and you would have gotten the same thing. It would have hardly made a difference. All right, so now I'm going to go ahead and combine my two equations together. So this is 9. Actually, since I already have this number on my calculator, I'm going to do this one first. So this would be 2112. The j cancels out, and now I can do this one, 9 minus 2.4, which is going to be, in this case, 6.6. Okay, now I'm going to find the price of the gummy bears. I know that 6.6 pounds would be $21. So a pound of gummy bears is 2112 divided by 6.6 would be 3.2. So there you go, 3.2. So we know the gummy bears are going to be $3.20 per pound. And a pound of gummy bears is actually a lot. I mean, like, it's like a lot. I'm trying to think what a pound would be like. But they're not really that heavy, and there's a lot, and gummy bears have a lot of sugar. It's a good thing this question isn't asking, well, what does he have? Because it'd be diabetes. Okay, anyway, let's go ahead and get this plugged into one of these. So I'm gonna go with the top one only because it looks like it has small, well, actually, since we're plugging in for G, actually I'm gonna use the top one here because something might happen here, just I wanna point out. All right, so we know that G is 1.8, so I'm gonna plug in 3.2. Oops, 26, not 25. There we go. Okay, now I'm gonna times this, because I know it's $3.20 for a pound of gummy bears, and this is 1.8 pounds, so it's almost 2 pounds. 5.76, so it's $5.76. And I didn't change anything on this side, so nothing would change. Now I'm gonna have to minus $5.76 from both sides. and that'd be $4.05. So 0.6J equals $4.50. So now half a pound, or well, 0.6 is a little bit more than half a pound, but roughly half a pound is $4.50. So if I divide that by 0.6, I should get my exact amount. So in this case, jelly beans, and I just divided both sides by 0.6. And this is a bit of a weird one because, you know, sometimes I do get students that go, how did that happen? So on my calculator, it says $7.50. So sometimes when you multiply by a very small number, you will get a bigger number. Okay, and I'm gonna, just to show you there's no tricks, I'm gonna go ahead and show you on my calculator here. So remember, it was $4.50 divided by 0.6. And that still comes out to $7.50. So sometimes you will get bigger numbers. And again, I will get students that say, how did that happen? What, you know, why is it doing that? That's not right. But I'm just going to show you again. Sometimes when you divide by a number smaller than 1, it actually gets bigger. Anyway, let's go ahead and write this down. So it says pounds. So I'm going to go ahead and put 1 lb for pound. 1 pound gummy bears is $3.20. And then I'm going to go ahead and do the second part for jelly beans. So for jelly beans, we got 1 lb jelly beans, and those were $7.50. And that kind of makes sense. Jelly beans are a little bit more expensive. I mean, gummy bears are not really, they're not really that expensive, and they're not really, I don't know. Between the two of them, I would imagine jelly beans are a little bit more expensive. I don't know if that's true all the time, but to me, it seems like it would be more true more often, just because, again, jelly beans are on the more expensive side. So I think that makes sense. All right. So looks like we are done with this one. Let's go ahead and keep things moving along. All right, so for this one here, let's see. Courtney has a total of 88 stamps worth $15.56. Some are 25-cent stamps and some are 2-cent stamps. So we're looking at 2 categories of stamps here. How many of each does she have? Okay, now this one was a bit of a tough one because for variable, I can't say S because they're both stamps. They would both be S. So one thing we could do is come up with an X or a Y is probably a better way of doing this. And with my other class, I did like big and small stamp, but I guess it was kind of confusing because the stamp didn't actually change size. It's just how much value they are worth. So in this case, the X is a 25. And I don't know how to put cent in there, so I'll just spell it out, cent stamp. I know there's a way to type the cent symbol, but I don't know how to do that. And then here, let's go ahead and get the Y value. So the Y is the 2-cent stamp. So there you go. We defined our variable. So now we know what we're looking at. So let's go ahead and try our best to make an equation. Now, sometimes, like I was telling you, how it's really easy to get the clue statements, as I call them, to work out because they're just written in a way that's easy to read. Now, in this case here, this is a bit of a tricky one because I would imagine that some students might look at this sentence and go, okay, well, 88 equals 1556. But then what do you do with this side, huh? See? So you're gonna have to think about it a little bit because some of these are gonna be out of order. So there are 2 things we're looking at. We're looking at the value and the number of stamps. Right, so value and the number. So we're gonna have to make an equation for each one. Now, it doesn't matter how much the stamp costs, one stamp is one stamp. So a small stamp, or sorry, a 25-cent stamp and a 2-cent stamp, no matter what, they would always come out to be 88 because they're only worth one each. Okay, so next is the value. So here we have 25 cents, and this one's a bit of another tricky one because we'd have to convert this to a dollar amount. So 25, you know, if I told you to write 25 cents in terms of a dollar, it would probably be something like this. And over here, we have y equals our 2-cent stamp, so 2-cent stamp. And now this is counting the value. So if I have like 4 of these stamps, that'd be a dollar. If I had 4 of these stamps, it would be 8 cents. So in this case here, now we're talking about the value. So this would be 15.56. So again, that one's a bit of a tough one to set up because, well, the wording is kind of all over the place. And it doesn't say anything about this one here. We had to kind of think this one through on the top one. Now, I'm going to do something a little bit different today. So remember, the direction says to use whatever method you want. So in this case, I'm going to do something a little bit different. I could probably solve this using elimination, but actually that might be a little bit hard because I'd have to multiply all my top number by, say, 0.25 to get rid of the x, right? And then I'd have a whole bunch of decimals to deal with. So I think an easier way, and if it's not easier, it would at least be a different way to show you how to do this, and that is to solve for one of the variables. So in this case, I'm going to solve for x, and I'm going to minus y from both sides. And as I minus y from both sides, it's going to be 88 minus y if I put it all in one line. Now I'm going to plug it into the other one. I'm going to plug it into this one here. So 0.25x plus 0.02y, but in this case I know, oh wait, no, I need to replace x, not y. So make sure you're plugging in for the right variable. Okay, 0.02y equals 15.56. Okay. Make sure I plug it in the right place, make sure I didn't change any of the numbers, and I think we are ready to go. So in this case, 0.25 times 88 would be 22 minus 0.25y plus 0.2y. And all I did was use the distributive property. But I still have a couple of other things to do. For one thing, I need to account for both of these y values. So I'm going to combine my two y values here as negative 0.25 and 0.02y. And that, so just think of it as this way, 25 cents minus 2 cents. Okay, that would be 23 cents. Again, 25 cents minus 2 cents, that's 23 cents. So I'm going to write 23 just like that. And this would actually be a negative number. So sometimes that happens where your negative number, well, just so happens to work out that your negative is bigger. I'm also going to have to minus 22 from both sides. And this is going to give me 644 or negative 644. Now, if I managed to work this out a little bit better, they would have been both positive. But again, this happens sometimes. Don't be afraid when it happens. I'm just going to have to divide both sides by negative 23 cents, which negative divided by a negative would be positive. And it doesn't make sense that you'd have negative stamps. So if you get a negative number, again, that should fail the sniff test because if you think about it, is it possible to have negative stamps? No, it's not possible at all. It's absurd to have negative stamps. And if I divide both sides by 23, so again, if I had $6.44 and I had to break it into as many 23-cent pieces as I could, I'd have 28 of them. So that means that we would have 28 of the 2-cent stamps. So there's one of our solutions. And we're going to have to send this back in to one of the equations to get the other side. And this is probably going to be a little bit messy. I'm going to move, I wonder if I can move this equation over a little bit here. Okay, I can't just move one little piece. So I'm gonna have to try my best to plug this into one of the original equations. Actually, you know what? I don't need to plug it in. Because if we have 28 2-cent stamps, how many of the 25-cent stamps could we have to make it equal 88? Well, that's easy. Just take 88 minus 28, and that should be how many of the other stamps you have. Because 28 plus 60 is 88. And we can check it 8, 0, 2, and 6 is 8, so that would be 88. So we don't need to plug it back in. We actually got our answer without having to do a whole lot of work. Okay, so we actually got both of them, and we didn't have to use the second equation. Okay, so let's go ahead and list our answer. So I'm going to go ahead and put 60 of the 25-cent stamps, and I'm going to move this down just so I'll have more space. And then so Y is the 2-cent stamps, and there are 28 of the 2-cent stamps. And I just changed the order just so that way the bottom one would be a little bit longer. Or maybe I could move all this again. Just so it all fits on there. There you go. Whew, okay. Luckily, I'm able to move my work around. All right, so let's go ahead and move on to this next one here. So now this one kind of threw me for a loop on the first one, because when I first read it, I was looking at the wrong variables because, well, let's read it. So Tom put in 18 gallons of mid-grade gas in his truck and filled up his empty 5-gallon gas can with regular gas for a lawnmower at home for $59.91. The next week, he put in 14 gallons of mid-grade gas in his truck and topped off his 5-gallon can with just 1 gallon of regular gas. If he paid $39.75 and the prices were the same, find the price per gallon of mid-grade gas and regular gas. So I actually, in my brain, I started thinking, okay, so one is for truck and the other is for lawnmower. And it wasn't until I read the final line in the question, and this is why it's a good idea to read the question first, because it actually told me here that we're looking for two variables of different kinds of gas, different qualities of gas. So again, I was looking at truck and lawnmower, so I was assigning already the values of T and L. And then R is regular gas. So M for mid-grade and R for regular. So those are our two variables that we're looking for. And again, too, this one almost, it's a little bit different because when I go to the gas station, I only buy one kind of gas and that's it. So I thought this question was talking about quantity of each gas tank or something like that. So that's why it's a good practice to read the whole thing before you start working on it. So let's go ahead and put this in here. So again, we have our exposition. This guy's putting gas in his truck, and in a way, it's a lawnmower as well. So let's go ahead and put down our first clue. So 18 gallons of mid-grade gas. So 18 M plus, now this is a tricky one because when it says an empty 5-gallon can. So it's empty, starting empty. He fills it up. With regular gas. So that means he bought 5 regular gallons of gas, and this was $59.91. And the next week he does the same thing, but with different numbers. So 14 gallons of mid-grade gas. And this one was a bit of a tricky one because it says topped off. When I hear the word top off, I think of filling it all the way up. So maybe it wasn't all the way empty. Maybe he only used 1 gallon and then filled it back up so it was back to full at 5 gallons, but he only put 1 in there. So that one also kind of got me a little bit confused too, because I was like topping off, but it also didn't say it was empty, so it probably wasn't empty. Anyway, so the second week was 39.75, like that. So there we go. Now we have both of the equations for the first week and the second week. Now, this one should be an easy one because I just need to change this bottom equation. And I would need to multiply it by 5, but I'm also thinking of -5 because, again, it has to be the same, but it has to be opposite of this one here. So let's go ahead and start working on this. So 14 times 5 would be 70, but -70. So -70m. So again, I'm taking this second one and I'm multiplying everything by -5. 1 times -5 is -5, and then r stays the same. So here I have 39.75 times 5, and that would be 198.75. And again, I'm going to have to ignore this equation here. Do my best to ignore it. I don't want to cross it out because I might need it again. So let's go ahead and do this one here. So 18 minus 170. That'd be 152. Wait, hold on. Maybe I pushed the wrong button. That doesn't seem right. 18 minus 70. There you go, regular 52. I don't know, I must have pushed an extra button on the calculator. But again, don't be afraid to give it the sniff test. If something doesn't seem right, back off of it. Okay, now for r, 5r minus 5r, that's going to be nothing. Cancels out, so that's good. And oh, you know what? I forgot to put a negative on this one here. And usually I check the steps because everything should be negative. Right? All the signs should be opposite. So we know, again, that's weird because we minus the last two numbers and now we should be minusing this number. 59.91 minus 198.75, and we get 138.84. Okay, now with this number here, I'm going to divide both sides by 52, and this should give me my the first part. So mid-grade gas is 267 per gallon. And again, I just divided both sides by 52. That's and this should be a negative also, which if they're both negative, negative divided by negative is positive. But again, there's no such thing that you would buy that is a negative price. Well, nothing you'd come across in your everyday life that would be a negative price. So, now that we have one of these, let's plug it in. Now, the reason I wanted to keep this one, and again, I didn't cross it out, is because it's already solved for R. R is already by itself. So that makes it very easy to plug in M. So 14M, and we already know it's 267 for the mid gas. And R is already by itself, so I won't have to do the last step where I divide both sides by something. I should be able to just times this. So 14 times 267 is $37.38. Now again, this was his total, right? He had to pay $39.75 for both of those kinds of gas. And he spent $37.38 on the regular medium, the medium mid-rate gas. So all I'd have to do is just subtract both of them, and I can see how much he had paid for that, and it'd be $2.30. I was looking at the calculator while I was reading it. $2.37 per gallon of gas. Because again, find the price per gallon. So that's usually how gas is sold. And I mean, I know you probably wouldn't have a car or anything like that, so you probably wouldn't know, or you wouldn't think to put gallons of gas. You'd probably just put gas. So let's go ahead and put the answer in there. Mid-grade is 267, and that's why I put M, so it's easy for me to read. M is 267. 267 / gallon, and that's, if you go to the store, that's the way it's going to be written. Okay, that's just the way it's written. And now we would do the same thing with the other line. So I'm going to see if I can fit it into this line. Regular is 237 / which means per gallon. Oh, forgot the $sign. Make sure we put them in given units. And I'm going to switch them on my side. You don't have to switch them if you're writing it, but I just wanted to switch them so that way the shorter one is on top, so it fits a little bit better without getting in the way of any of the stuff that I wrote on. And I'm not sure if I can move this out of the way too. I can just take all this and move it over as well. Although this line is not going to match up anymore. Oh, wait, no, that's a different thing. Anyway, so that works out for that one. Okay, so another one down. Let's move on to the last series of questions. And again, be careful with this one here. It almost tricked me because I did not look at the question. And I just started working on it. So I wasted like a minute setting it up for something that I didn't even have to work for. All right, moving on to the next one here. So this one's a really tricky one. I think if I ever saw this on a homework problem, I'd probably just, I'd get rid of it. I'd just say cross it out. But maybe you'll get something out of this one. So we might as well just cover it. So this one's, again, has a bit of vocabulary that you might not be familiar with. And this actually does require a little bit of background knowledge to fully understand. So a total of $12,000 was invested in 2 types of bonds. So now we know we're looking at 2 different kinds of bonds. There's the X bond, I'm going to just call it X bond, and then Y bond. So this basically means a type of investment. So again, we just have X and Y to keep it simple. One pays 8% simple interest while the other pays 10.5% interest. Last year, the annual interest earned on the 2 investments was $1,145. So how much was invested at each rate? So again, this one is a tricky one because it's like the wording is all over the place. And which numbers do you grab for what? All right, so a total of 2 types of bonds. So we had the X bond and the Y bond, and that was 12,000. And the other one here, and this is the other part that's kind of tricky because in this case here, they're talking about the interest to the amount. So one pays 8%. So 8% is written like this. And we'll call this one the X bond plus the other one that pays 10.5%. Now this is another tricky one. So 10.5, what does 10.5 look like? So 10%. If I was going to write 10%, like 10 cents, it would look like this. And actually, you do see this on gas stations where it says 9/10 of a cent afterward. But in this case, I would just put a 5 at the end. And again, this is a weird number. You wouldn't normally see something like this in dollars or percentages that often. Well, if you do a lot of work in banks or something, it would probably mean a little bit more. And in this case, we got 1,145 here, like this. Now, this is a pretty good one to use. What do you call that thing? Substitution method. And I'm going to use substitution method because it looks like it's going to be really easy to solve for one of them. So what I'm going to do is I am going to solve for X. So that means I'm going to minus Y from both sides. And if I minus Y from both sides, it stops being over here with the X and it moves over here. So I'm minusing Y now. Now the next thing I'm going to do is I'm going to take this and plug it in for the other X. So now I know that's 1200, sorry, 12,000, yeah, 12,000 minus y. And then I'm going to have to continue writing the same thing. So 0.0105 y equals that number. So I just plug it in. Take this and plug it in. So plug this in for x into this equation, and it gives us this. And now I'm going to go ahead and multiply both of these. So 0.08 times 12,000, and that's going to give us 960 minus 0.8 y plus 0.105 y equals 1145. Now I'm going to have to combine these two things here. So 10.5% minus 8%. So again, this one is a bit of a tricky one, and I probably wouldn't really have this all that much in a problem like this. So I'm going to go ahead and combine these so that I get okay, so I already have it on the calculator, so I'm going to just go ahead and do the 1145, and this would be 185. So 185, and this is the other side. This is going to be this side here. And I'm going to have to combine these two things. So 0.105 minus 0.08, and that would be 0.025. So that's a really small number. That's like 2.5%. So for some people, that number may not make a lot of sense to them. And here's another thing too. So there's that same idea coming back again. So we're dividing by a very small number. So we're dividing by a very small number. So in this case, we are taking 185 and we are dividing it by 0.25 like this. And that should give us 7,400. So again, sometimes this looks weird because this kind of goes against what some people think. Some people, they think, well, if you divide, you're always supposed to get a smaller number. But sometimes you can divide and get a much larger number. So 7,000. Oh wait, so in this case here, we're talking about the Y bond. So the account Y will yield $7,400. Okay, so now that we know this gives us, and the good thing about this one is that we don't have to, we can plug it back into, say, one like this. So if I want to plug it in, I know that Y, so I get X plus Y, but I know that Y is 74,000. So what number would I need to add to 7,400 to get 12,000? So I'm going to minus 7,400 from both sides, and that gives me what I'm looking for. So X equals 46, I said 4,600 or 4,600. Both are right. So there you go. How much was invested at each rate? Okay. So this is going to be another hard part because now I'm going to need to move some of this over to get all my answer in there. See if I can get all this moved over. Okay. Now, because I need to write a lot of this. So X, so remember the X was the 8%. So how much money was invested at each rate? So looking at X, so 4,600 invested at, and again, this is our X value, and the X value was 8%. And then over here we have 7,400 was invested, so that's our Y value, And the Y here, we signed our, that's our 10.5%. And again, this is a very tricky question. This is the kind of question that if I saw it on a homework, I'd be like, I'm going to take that off. We're not going to do that. I'm not going to expect you guys to do that. Just the vocabulary alone is a lot of work, and it also doesn't really give you, like if it said something like, you know, account A or account B or X, account X and account Y or something like that. Instead, it just says two types of bonds, and I think a lot of people, you know, would see the word bond and it'd be like, I don't even know what I'm doing here. So again, I'm glad we went over that. It's at least helpful. All right, now this one's another one because we've already seen two problems that look a lot like this, where we're looking at coins. But this one's gonna also be a little bit different too. So a collection of dimes and quarters is worth $9.55. If the quarters and dimes, sorry, if the quarters were dimes and the dimes were quarters, the value would be $7.60. Find the numbers of each coin. So another one, this one's a really tricky one because we've never seen a question like this where it says, if the dimes were quarters and the quarters were dimes, so basically we're switching the value. Okay, so let me go ahead and do this one. So a quarter is 25 cents plus a dime. And I'm gonna put 10 like this because that's how you would say 10 cents, and that's for a dime. And the true value is $9.55. However, there's going to be another one, and this one's a tricky one because again, it says if quarters were dimes and dimes were quarters. So I'm going to show you what I'm going to do here. So I'm going to end up erasing this, so you're going to have to get this down. So if I were to get the value switched, so we have quarters plus dimes, and this is if they were to switch places. That would mean this would be 0.10. Oops, put the 0 in the wrong place right there. And dimes were quarters. So we switched the value of them. And this works out pretty good. It works out okay. So next thing we'd have to do is figure out how to eliminate one of these. So which one could I eliminate? All right, so I'm gonna go with different values. So I'm gonna multiply this top one here, multiply it by, now where would these meet up at? This is pretty easy because they both meet up at 50 cents. So I'd need to multiply this by 2, and I'd need to multiply this one by 5. And one of them has to be the negative value. Okay, one of them has to be the negative. So I'm gonna have to multiply this one by negative, maybe. I'll make the bottom one negative. I don't know. It's just, again, that's just kind of how I do things. All right, so let's go ahead and take this one, and this would be 0.50 cents Q plus, and then again, we're timesing all the top stuff by 2. 9.55 divided by 2. I'm pretty sure that'd be like 1905, maybe 1910. 9 times 2. Oh wait, oh, I must have pushed the wrong button. That's not right. 1910. Okay, $19.10. Okay, and then the bottom one, I'm gonna have to multiply everything by negative 5. And I'd like to put the 0 in front just so that way it's easier to see what you're looking at. And then let's see, 5 quarters would be $1.25. Oh, and it's negative too, don't forget the negative. And that is dimes equals, and now let's see, 760 times 5, 7.6 times 5 would be $38. Now I'm going to have to combine those two equations. And I'm going to just put it right over here. Oh, wait. Almost forgot again to make this into a negative. Say, double check your steps. Okay, don't trust yourself on some of these things here. Okay, it's good to have faith in yourself, but sometimes when you're doing math that requires a lot of change of signs and change of numbers, don't trust yourself as much. Okay, so let's go ahead and do this one. Now this one should cancel, so I can move on to this one here. So this is 0.2 minus 1.25, and that would be 1.05. And that would also be a negative because I'm subtracting the larger number as the negative. And that would also mean that this side would be negative. Now again, you cannot have a negative number of coins. So $19.10 minus $38, it's going to be $18.91. $18.91. Okay, and again, there you go. I'm gonna have to, I'll just put it up here and draw an arrow to it. So this one and this one both became this one here. All right, so now, oh wait, this would also be a negative as well. All right, so let's see how much we have. So divide this by 1.05, and that would be 18. So dimes equals 18. All right, so there we go. So we got one of them down. Now we got to find the other one. So to find the other one, let's pick one of our original equations and plug it in. I want to use this one here just because it's more closer, because we know quarters are 25 cents and you know dimes are this much. So if something goes wrong, it's a little bit easier to spot what's going on. And we're looking for quarters, so we don't know the quarters. And we know that there are 18 dimes. And this comes out to $9.55. So I'm going to just move this over here. And I'm going to shorten this a little bit. Okay, and now let's start working this out. So again, quarters, nothing has changed with quarters. Plus, and this is going to be another easy one because this is just going to be $1.80. So we know there's $1.80 worth of dimes. And again, timesing stuff by 10 is pretty easy. And I'm going to minus $1.80 from both sides. And we know that if we ignore all the dimes, there's going to be okay, this doesn't really seem right. Is something going on here? Okay, maybe I plugged something in wrong, because there's no way we can get $8.45 from quarters. All right, see 2.5, that is $9.55, and that is the original equation. All right, something has definitely gone wrong here. There's definitely 18 dimes. 18 dimes would be $1.80. Maybe I minus the thingy wrong. So 9.55 minus $1.80. Oh, that's 7.75. Okay, I must have pushed the wrong button on the calculator. Whew. Okay, not a very good track record today. So there we go. Well, now we have $7.75 in quarters. This is a little bit more likely because now you can get that many in quarters. So counting the number of quarters, that would be 31 quarters. And this is a lot easier to write down. So we can say 31 quarters And the next one would be 18 dimes. There you go. That was a little bit, okay. Yeah, it just threw me for a loop on that one right there. I must have pushed the wrong button on the calculator or something, maybe a 5 instead of a 0 or something, and it just didn't work out as good. But again, too, there's always that thing when you're looking at it, when you're going over these problems, you got to kind of ask yourself each step, okay, so what does this mean? And with most of these, I've been trying to show you the meaning of each step. So it's not just about, doing math stuff. Okay, so I say stuff like ignore this cost or remove the calories from the cheeseburger. So there is stuff going on. It's just a little bit, you have to kind of keep up with it and kind of understand what's going on. Anyway, but as long as you do the elimination, the substitution, and you could probably even graph some of these too, although the graph is going to be a little bit weird because in this case, you'd have a lot of decimals in your graph, and over here you'd have really big numbers like 12,000 in your graph, and looking for the place where they cross might be a little bit difficult, although not really, I don't think it'd be really that hard, but anyway, so there we go. So that's it for today. So that's it for today. I will see you later. Bye-bye. Okay.
Hold on. Is tomorrow early dismissal?
So.
Okay, thank you.
All right. Hope that answers your question. Thank you. Thanks for stopping by. All right. Bye-bye now.
Bye.